want to help you prepare for this test coming up, and I'm going to work through the problems on this test review sheet, and this front side of the review covers sections 11.2 through 11.5, and then we've got some review on the back side. Just want to try to keep this material fresh as much as possible. So let's take these first three problems that are related to this gardener planting bulbs. Initially on October 1st, 20 bulbs are planted, and then as you can see if you read the problem, she's planting basically 3 bulbs every day. So we're basically adding 3 to the number of bulbs that are being planted each day. And so what we have here is an arithmetic sequence, because an arithmetic sequence involves adding the same number each time to get to the next number. And since we're adding 3 each time, that's what makes this an arithmetic sequence. So let's first of all get you once again exposed to the explicit arithmetic formula. This helps you find any nth term of an arithmetic sequence, and then we'll fill in the actual numbers. So you can find any nth term of the arithmetic sequence by taking the first term plus, don't forget plus, and that's easy to remember if you remember that this is arithmetic and that involves adding the same number each time, then you should be able to remember the plus sign here. And then in the parentheses, we have n, which will be whatever term we're looking for, minus 1 times the common difference. Okay, well, let's plug in the actual numbers for this particular problem. Write an explicit formula to model the number of bulbs she plants each day. Okay, well, that number will be the first term, which is the number of bulbs she planted on the first day, plus n minus 1 times the common difference, which we said is 3. She's planting 3 bulbs each day. Okay, so that's our answer for number 1. And then number 2, we're going to get more specific. How many bulbs will she plant on the 15th? So in this case, I'm going to let n in my formula become 15. A sub 15 is equal to 20 plus, and then again, n is 15, minus 1 times 3. And so continuing on, just simplifying, our 15th term, the number of bulbs planted on the 15th day, will be 20 plus 14 times 3. 14 times 3 is 42. 14 times 3 is 42. Plus 20 makes 62. Okay, so our 15th term, or the number planted on the 15th day, is 62 bulbs. All right, and now how many were planted in total? So this is wanting a sum of all the bulbs planted for all of these days. And since this is an arithmetic sequence, then adding all the terms of a sequence makes it an arithmetic series. And the way we find the sum of an arithmetic series, once again, is we can find the sum of any number of terms by doing the number of terms divided by 2 times the first term plus the last term. Okay, well in this case, we're looking for a number of bulbs planted for 15 days. N is 15. So once again, 15 divided by 2. The first term is the number of bulbs she planted on the first day, which is 20. The last term we figured up in number 2 is 62. All right, so in your calculator, you're basically going to do, you can do it a couple different ways. This is 7.5 times 82. All right, and if you grab your calculator, 7.5 times 82, you get 615 bulbs. All right, so this one you might want to do a couple of times, 2 or 3 times, until you get really comfortable with the formulas that are going to be required for each part, 1, 2, and 3. So that's your complete answer for those first 3 problems. So let's move on to number 4. And number 4 is involving arithmetic mean. We have an arithmetic sequence. So the first thing I'm going to do is target this term that goes in the very middle. And arithmetic mean says I'm going to take the term on the left, negative 17, and I'm going to add the term on the right, 1, and then I'm going to divide by 2. So negative 16 divided by 2 is negative 8. All right, so now I can use these 2 terms to find this first blank on the left. So once again, arithmetic mean, negative 17 plus negative 8 divided by 2. So negative 25 divided by 2 is negative 12.5. Okay, and then do the same thing over here. Take these 2 terms, negative 8 plus 1 divided by 2, and that's negative 7 divided by 2, which is negative 3.5. All right, now let's work on geometric mean. Notice this is a geometric sequence, so once again I'm going to target the middle term first. The geometric mean is a little different. It's the square root of the product of these 2 outside terms. So 12.5 times 5.12, and let's see what the square root of that product is. The square root of 12.5 times 5.12, and that is 8. So my very middle number here is positive 8. So now I'm going to do geometric mean to find this first blank, and once again it's going to be the square root of 12.5, and this time it will be times 8. All right, so calculator, square root 12.5 times 8, close your parentheses, and that's 10. All right, and then do the same thing here. Let's find the geometric mean, square root of 8 times 5.12. All right, square root 8 times 5.12 is 6.4. Okay, so we have our missing terms. Just read the problems carefully. If you're dealing with arithmetic sequences, arithmetic mean is really finding the average. Geometric mean means the square root of the product of the 2 numbers on either side of the missing term. Okay, so let's move on to problem number 6. And this is a little practice on writing the explicit formula for a geometric sequence. And how do I know that this is geometric? Well, because I'm given the common ratio. If I had been given D, then I would have been told basically that this was arithmetic. Okay, so once again, let's just look at the formula in general. The explicit formula for a geometric sequence looks like this. You can find any nth term by taking the first term, and now this time we're going to be multiplying times r raised to the n minus 1 power. Okay, so the explicit formula looks like this. I can find the nth term for number 6 by taking 3, multiplying by 4, and 4 then will be raised to the n minus 1 power. Okay, that's the explicit formula. And now use that formula to find the, in this case, the 10th term. So now I'm going to let n become 10, and 3 times 4 to the 10 minus 1, which makes 9. All right, so make sure if you do this in your calculator, your calculator will do it for you, but if you're going to try to break this apart into two parts, make sure you follow the order of operations. So we're going to do 3 times 4 raised to the 9th power, and we get 786,432. All right, so very similar problem over here. The explicit formula, find any nth term of this sequence by taking the first term and multiplying times the ratio raised to the n minus 1 power. Using this to find the 32nd term means I'm going to let n become 32. And once again up here I'm going to let n become 32, which means my exponent becomes 31. And depending on the calculator that you use, you may end up with scientific notation. This is not the type of decimal answer I will give you on the test. So you're going to be left with this answer, negative point, and then there is 1, 2, 3, 4, 5, 6, 7 zeros. And then 1, 5. And that is our 32nd term of this geometric sequence. So once again, a lot of formulas. Make sure you practice the problems so you know which formula is connected to these particular problems. Very important. All right, for number 8, we are given summation notation, 8 and 9, and we've got to find 4 basic things. The number of terms, so I'm just going to do A will be number of terms, B will be first term, and C will be last term, and then using the necessary formula to evaluate just means find the sum of the series, we'll let that be letter D. Okay, well, how many terms? Well, you can always do this. You can take the top part of sigma, in this case 85, subtract the bottom number, 1, and then add 1. So the total number of terms for number 8 will be 85. B, what is the first term? Well, to find the first term in summation notation, just take the bottom number of sigma, plug it in for n, and simplify. If we let n be 1, 1 minus 1 is 0. All right, how do I find the last term in summation notation? Well, this time I'm just going to take the top number, plug it in for n, and simplify. So if n is 85, 85 minus 1 is 84. And then number D, letter D says use the necessary formula to evaluate the series. Well, this is an arithmetic series. And the way I find the sum of an arithmetic series, we looked at it back in number 3. I'm going to write it again just so you can see it. Number of terms divided by 2 times first term plus last term. Okay, so we've already figured out pretty much everything we need for this formula. Number of terms, 85 divided by 2. First term is 0. The last term is 84. So let's use our calculator. 85 halves times 84 is 3,570. Okay. Just double checking that number. All right. So very similar problem with number 9. So let's do the same thing to get the number of terms. We can do this. 15 minus 4 is 11. But don't forget to do plus 1. So their number of terms here is 12. B, what's the first term? Well, just take the bottom number of sigma, plug it in for n, and simplify. So negative 4 minus 3 is negative 7. That's the first term. Letter C, we're calling the last term. Well, this time just take the top number and plug it in for n and simplify. And negative 15 minus 3 is negative 18. And then we're going to use this same formula that we used over here. Number of terms divided by 2 times the first term plus the last term. And we end up with 6 times negative 25, which is negative 150. All right, so far so good. We're moving right along. Let's see what number 10 and 11 look like. Well, this time we're going to be given part of a series, and we've got to come up with the summation notation. Remember, that involves sigma. And so I'm going to go ahead and do the part that's always going to be true for you. We're going to make the capital sigma. The bottom part will be n equals 1 if you're writing it from scratch. The top part in this case, for number 10, the top number will be 25. But we're going to have to do a little work to come up with this expression. And this is a familiar formula for you because it's the one that we use to find a term in an arithmetic sequence. Remember that? Looking back at number 1, we use this in number 1 and 2 actually. So let's see if we can simplify this to come up with the expression that will be placed here to the right of sigma. So the first term is 4. Notice I'm not going to put a number in for n. The common difference, since I'm going from 4 to 9 to 14, the common difference is 5. Okay, so I'm going to do the distributive property. 5 times this parentheses. And then I'm going to combine like terms. And I come up with the expression that is placed to the right of sigma. And notice, since it's a binomial, then I must use parentheses. Now you can check this yourself just doing some mental math. Let's see if we at least get these first 3 terms that are shown. First of all, if we want to find the first term, let's let n be 1. And if we let n be 1, 5 minus 1 is 4. Okay, that checks. To get the second term, let's let n be 2. 5 times 2 is 10, minus 1 is 9. That checks out. What about the third term? N is 3. 5 times 3 is 15, minus 1 is 14. So you don't have to guess. You don't have to wonder if this expression is correct. You can do your own little check, especially if you finished early and you've got time on your test. Just check this out and make sure at least these first 3 numbers, or however many numbers you're given, you can come and you can arrive at those numbers by using this expression. All right, let's try this one. So here's my sigma, n equals 1, 15. Let's see what this expression is going to be. So it's the first term plus n minus 1 times the difference. Well, let's see, I'm going from 17 to 25. That's 8. 25 to 33, 8. So my difference here is 8. And I'm going to do the distributive property. 8 times n, 8 times negative 1. And then combine the constants. I get 8n plus 9. So I'll make sure to put that in parentheses. And let's just do a little check. Let n be 1 for the first term. 8 plus 9 is 17. Okay, well, let's let n be 2 for the second term. 8 times 2 is 16, plus 9 is 25. That checks out. N equals 3 for the third term. 8 times 3 is 24, plus 9. That's 33. So I'm feeling good that I got this correct. Okay, the one thing we haven't done yet is evaluate the series. Well, once again, that same formula. I'm going to evaluate an arithmetic series, which both of these are. Number of terms divided by 2. Get a lot of practice with this formula. First plus last. Okay, so let's do that over here. The number of terms, 25 divided by 2. The first term is 4. The last term I don't see because remember there's 25 terms here. I can only see the first 3. But it's easy enough to find it. If I just take this top number above sigma, plug it in for n, and simplify. So 5 times 25 is 125, minus 1 is 124. So let's see, 12 and a half, that's 25 over 2. 12 and a half times 128 is 1600. So the sum, or evaluating the series for number 10, we get 1600. Okay, and let's go ahead and do this one over here. Number of terms divided by 2. First term is shown. Last term I can't see yet, but let's figure it up. Let's just let n be 15. 8 times 15 plus 9 is 129. It's my last term. So 15 over 2, which is 7.5, times 17 plus 129, and we get 1,095. Okay, so we got our complete answers now. Here's the summation notation, the evaluate, summation notation, evaluate. All right, let's check out numbers 12 and 13. Use the necessary formula to evaluate each series to the given term. Well, this is a finite series because I'm told to stop at the 10th term. And I also notice that going from one term to the next, it looks like if you do 20 divided by 40, that's a half. 10 divided by 20, that's a half. So these are geometric series. And they're also finite, as I mentioned earlier. So let me just show you basically. Oh, it's on A. We're looking for the sum. The sum of a certain number of terms for a finite geometric series. I'll just show it in variables and then we'll plug it in. First term, 1 minus r to the nth power divided by 1 minus r. Okay, specific to this problem, summing through the 10th term will involve the first term times 1 minus the ratio. So once again, if you're looking for the ratio, just put these first two together and divide. Second divided by the first, 20 over 40 is 1/2. We're going to raise 1/2 to the 10th power. And in the denominator, we're going to do 1 minus 1/2. So let's grab our calculator. And we can probably do pretty much all of this in just one line, 40. And then parentheses, 1 minus, and then I'm going to put 1/2 in parentheses. And I'm going to raise 1/2 to the 10th power. Close parentheses. And then I'm going to divide by, I'm just going to go ahead and divide by 1/2 instead of dividing by 1 minus 1/2, because we know that 1 minus 1/2 is 1/2. All right. And the result is 79.92 after rounding. Okay, 79.92. So make sure that you can use your calculator properly to come up with this number. All right, let's try this one. It's also a geometric series. This time the ratio is 3. I'm multiplying by 3 each time to get from one term to the next. 12 divided by 4 is 3. 36 divided by 12 is 3. You get the idea. So let's find the sum of the first 15 terms of this series. First term times 1 minus, this time it's 3, raised to the nth power, which is 15. All right, and then in the bottom we'll have 1 minus 3, which is r. Okay, once again, let's grab your calculator And this time we're going to do 4 parentheses 1 minus 3 raised to the 15th power. And I'm just going to say divided by -2 instead of putting divided by 1 minus 3. And my result is 28,697,812. All right, so once again, practicing this formula, making sure that you can use the formula properly with your calculator. That's important. Some people know the formula, but they're not using their calculator properly, like with parentheses in the right place and so on. So if you're having questions about that, come see me and let's get those worked out before your test. Okay, now we're using another formula, but notice the difference between these problems and the previous problems are these are infinite series. And this didn't show up very well, but that's the symbol for infinity, also infinity. So these are infinite series, and we have a different formula for an infinite geometric series to find the sum. The sum is found by taking the first term and dividing by 1 minus r. So it's pretty quick and easy. For number 14, the first term is 8, divided by 1 minus r. And once again, if you're looking for r, just put these first two together and just do division. The second one divided by the one before it, and r is 1/2. And I want you to stay away from your calculators here. 8 divided by half, of course this comes out anyway as a whole number. 8 divided by half is the same thing as 8 times 2. So my answer for number 14 is 16. Okay, another infinite series here. If you're looking for r in summation notation, the geometric series is represented by summation notation. The r is always found by whatever is directly below the exponent n minus 1. It's the base for n minus 1. So in this case, r is going to be 1/4, and the first term will be the number that's in front of r. And if there is no number showing in front of r, it's assumed always to be 1. So to get number 15, we're going to do the first term, 3, divided by 1 minus the ratio. Okay, that's 3 divided by 3/4. 1 minus 1/4 is 3/4. And dividing by 3/4 means multiplying by 4/3. And you can look at this two different ways. You could say 12 over 3, which is 4. Or if you just look at it this way and cancel these diagonal 3's, you would still get 4. So my answer for number 15 is 4. Can't really do anything on number 16. I can't find a sum anyway, because remember, for an infinite series to have a sum, this has to be true. The absolute value of r has to be less than 1. Well, that was true on these two. R is 1/2. That's less than 1. 1/4 less than 1. But in this case, r is 1.2. And obviously 1.2 is not less than 1. So all we're going to be able to do on this one is write the word diverges, which means basically there is no sum that can be found for this geometric series that continues infinitely. All right, now we're on the back side, and this is review. And for some of these, like number 17, it goes back a ways. Just want you to keep this as fresh as we can, because you're going to see this again in a pre-calculus course, maybe a calculus course down the road. Okay, so find all the roots. It's another word that we could think of as solutions. And since this is a cubic polynomial, remember the degree will tell us how many solutions we're looking for. And in this case, we're trying to find 3 roots. And if it were quadratic, it'd be a little bit easier because I've got the quadratic formula. I could maybe factor if possible. But it's not, it's cubic, and so we have other ways of solving for these cubic polynomials, finding the roots. And one way involves what is known as the rational root theorem. And here's how we use the rational root theorem. We do the factors of the constant, the last number, which in this case is -1. I'll just say factors of the last number and of the polynomial. You know that means -1. So all the factors of -1, well, that's pretty easy. It's positive and -1. And underneath that, we're just going to make a little fraction. We're going to do the factors of the first number. Okay. And what we're talking about here is the very first coefficient of the polynomial, which is 2. Well, the factors of 2 are positive -1 and positive -2. Those are the only numbers that we could multiply to get positive 2. So from this fraction, we have possibilities for rational roots. That's why this is called the rational root theorem. We have 4 numbers that are possible rational numbers that could be roots. And hopefully you can see that those numbers are 1, -1, because we get both of those from just putting these together over each other. We also could make the numbers 1/2 and -1/2 from these. So all in all, we have 4 different possible rational roots. And we're going to use those in a table. So I'm just going to list these possibilities. And I'm about to set up a table so that I can do synthetic division. So across the top of my table, I'm going to use these coefficients and the constant -1. And we begin the synthetic division process. It always starts by bringing down this first number, this first coefficient. You multiply to the number on the left, 2 times 1, which is 2. 2 plus -1 is 1. And repeat, 1 times 1 is 1. 1 plus 2 is 3. Now this number, 3 times 1 is 3. 3 plus -1 is 2. Well, the goal is to find the number on this side of my table that will give me a 0 remainder. Obviously 1 did not do that, so I'm going to keep looking. And we'll test -1. 2 times -1 is -2. -2 plus -1 is -3. Positive 3 when I multiply, plus 2 is 5. And I can see right now, -5 plus -1 is not 0, so I'm just going to keep searching. I'm going to try the next number. 2 times 1/2 is 1. 1 plus -1 is 0. 0 times 1/2 is 0. 0 plus 2 is 2. 2 times 1/2 is 1. 1 plus -1 is 0. So I have found the rational number that gives me 0. I found one of the 3 roots, and I'm going to circle it here to show that that's one of my solutions. So I'm looking for 2 more. Well, the nice thing about this is these numbers are going to represent an equation. This first number is a quadratic coefficient. Since I divided into a cubic, I now have a quadratic result. Okay, so I've got 2 in front of x squared. This says I don't have any x term. There is no linear term. And I've got a constant. And I'm going to let this equal 0. And after I solve this equation for x, I will have my other 2 roots to go along with 1/2. So solve for x, just like we've been taught many times. The first step would be to subtract 2. Divide by 2. And now do the square root of both sides. Don't forget plus minus. So we're left with x equals plus minus the square root of -1. Well, I don't want you to leave this because we have a number that is equal to the square root of -1. And it's the number I. We learned about that way back in chapter 6. So the simplified way of writing the square root of negative 1 is I. So to go along with positive 1/2, my other two solutions are I and negative I. Okay, let's take a look at number 18. This is a log equation. So my goal here is to put these two logs together as a single logarithm so that I can then change it into exponential equation form. Well, you remember back in chapter 8, before I could put two logs together as a single log, any numbers that are being multiplied times the log have to be moved. I think of it as clearing the space in front of log. So I have a property, it's called the power property, that says I can move these numbers, make them become exponents. So that needs to be done first. Okay, now these two different logarithms need to become one single log. Now, some of you are still in the habit of doing this. Now I'm about to do something that's wrong just to make a point. This is not one single log. You've just taken these two. You understand the quotient property fine, but you don't understand the idea of making one single log out of these. Now that was terrible. That was not good. Here's what we need to do. Log single of the fraction x squared over 3 equals 2. Okay? Kind of defeating the purpose of writing a single log if you're writing two different logs in the fraction. Because the goal here is to take this equation and write it in exponential form, because when we do that, it's going to be easy to solve with our calculator. Well, to write an exponential form, we need really two main things. We need a base, and I don't see a number down here as a base, so we learned that that always means that the base is 10. Okay? Well, to be an exponential form, this base has to have an exponent. And I learned back in chapter 8 that logarithms are exponents. And so this log is really telling me what the exponent is. It's saying the logarithm is 2. Logarithms are exponents. So 10 to the second power, and then on the other side of this equation will be the fraction x squared over 3. All right, so we know 10 squared is 100. To solve for x, I'm going to multiply by 3 on both sides. And then, sort of like our previous problem, we have to do the square root of both sides. Don't forget plus minus. And the square root of 300 is 17.32 rounded to the nearest hundredth. Okay, and we know we've been trained many times to always do plus minus when it's an even number root. However, when we're dealing with logarithms, it's impossible, it's mathematically impossible to do the log of a negative number. And if I put negative 17.32 in place of x, that's exactly what I would be doing. I'd be attempting to do something that's impossible. Therefore, even though I started off with plus minus 17.32, since I would be doing the log of a negative number, I'm going to consider only the positive as the answer. So my final answer here is 17.32. All right, number 19. This is just going to be an exercise in factoring and canceling. So these, if you can factor, these should be pretty easy for you. Let's just factor this first numerator. That should be pretty easy. That's an Algebra 1 type factoring deal. Factors of -6 that add up to -1 are -3 and +2. This denominator 4x cubed is prime. X plus 1 is prime. This factors, we can come up with two linear binomial factors of x plus 3 and x plus 2. Okay, and then we're going to look diagonally, we're going to look vertically, and we're going to see what cancels. Well, binomials that match will cancel. I cannot break apart a piece of a binomial, so don't attempt to cancel x with x cubed. That's not going to be good. Basically, a binomial has to cancel with another matching binomial. So what I have here is, that's it. That's all that cancels, and I'm just going to show whatever doesn't cancel will show as being multiplied together. I'm not going to ask you to go ahead to multiply them. I mean, if you want to, that's fine. I wouldn't take the time to do it because you might be short on time on the test. But this is sufficient for the answer. And that's it. So make sure you're up on your factoring. All right. Number 20. We are going to write an equation of a parabola with a vertex at the origin and directrix at x equals -3. So I always recommend drawing a little sketch. So let's draw what we're given. X is -3. All right, there's my directrix. Okay, vertex is at the origin. So what does this tell me about this parabola? Well, the one thing I do know is that the directrix is on one side of the vertex, 3 units away, and the focus is on the other side of the vertex, also 3 units away. So without even being told, I know that the focus is at the point 3, 0. We've learned that the vertex is right in between this point called the focus and this line called the directrix. So I can also conclude that the parabola opens to the right because the focus is inside the mouth of the parabola. So I can take it a step further. I know that the equation for the parabola that opens to the right is x equals a positive y squared. So if I could just figure out what this a number is, I would be finished. Unfortunately, we've got a formula that will help us with that. So this is the formula that you use a lot with parabolas. The absolute value of a is equal to 1/4c. Well, we got to understand what c refers to. And c always means distance. C is distance from vertex, which we're told is at the origin, to the focus. So in this particular problem, c is 3. So when I put 3 in for c, I get a is 1/12. So I am finished with this. I just replace a with 1/12, and I've got my answer. So that is your answer for number 20. X equals 1/12 y squared. 21. Write the equation of a circle with center given, and we're not given the radius. Well, let's start by reviewing the equation for a circle. Okay, I'll write it up for you. All right, these variables h and k represent the center, and r is radius. Okay, so we can go ahead and replace h and k. H would be -2, so if I put -2 in place of h, I'll put it like this first, but really we should write that as +2, shouldn't we? Subtracting -2. So that's going to be x plus 2, and k is 3, so this is going to say y minus 3. So that part of my equation is done. The difficult part is I don't know what r is. But by being given a point on the circle, and I know that for a circle, all points are the same distance away from the center. So if I could just find out how far apart these 2 points are, I will have the radius. Well, fortunately, I learned back in Algebra 1 how to find the distance between 2 points. It's the old distance formula. So I'll write it up for you and then we'll fill in. We're basically going to take the 2 x coordinates, subtract them, and square, And then we're going to do the same thing with the y coordinates. Now I'm calling this distance, and it really is, but we could get more specific and call it radius. Because that's really what this, in this problem, that's what this is going to mean for us. It's going to be the radius of the circle. All right, so let's take the two x's, -2 minus, and we're going to be subtracting -1, and that's going to be squared, plus 3 minus +1 squared. All right, let's simplify. Well, this is -2 plus 1 in the parentheses. Remember, we do parentheses first. So -2 plus 1 is -1. And -1 squared is +1. Plus 3 minus 1 is 2. 2 squared is 4. So the radius is the square root of 5. But my equation for a circle says radius squared. So just think of taking 5 and raising it to the second power. Or in other words, square root of 5 times the square root of 5. Well, that's the square root of 25, but what is the square root of 25? Well, it's just 5. So anytime you square a radical like this, the effect is just to remove the radical. And so I'm left with 5 as the r squared. So this becomes my answer for number 21. We are moving. Number 22. Write the equation of an ellipse with foci given, covertices given. Well, you need to know right away if you see ellipse and you're trying to find a missing part, which in this case we're not told what the vertices are. So for an ellipse, if you're trying to find missing part, whether that's foci, vertices, or covertices, you've hopefully practiced these enough to where you know that this is what we use for ellipses. And it might be a good idea if you see foci, maybe you just label foci as C, and covertices can always be labeled as B. So what we're missing is A, and therefore A squared. Well, if C is 5, C squared is 25. I'm searching for A squared. If B is 3, then B squared is 9. Adding 9 to both sides, I get A squared is 34. Okay, so I have my A squared and I have my B squared, and this much of my equation for an ellipse I know because it never changes. X squared and Y squared never change. So what does change is the location of A squared and B squared based on which is the major axis. And I notice that the foci are on the Y axis. And I also know that foci are on the major axis. So that means underneath Y squared, since Y is major, I'm going to place A squared, which is always the bigger denominator. And B squared, the smaller denominator, will go underneath X squared. So that is my answer for number 22. 23, the equation for a hyperbola. Foci, we can go ahead and do the same thing. Foci is C. This time we're given vertices, and vertices are always labeled A. So for hyperbolas, we're actually going to use the Pythagorean theorem to find any missing pieces. In this case, we're looking for B squared. So if C is 8, C squared is 64. A is 5, so A squared is 25. So solving for B squared, we get 39. Now hyperbolas are a little different. In this case, I'm going to write the part that never changes. First of all, hyperbolas have minus. A squared is always the first denominator. B squared is always the second. That never changes for hyperbolas. What does change is where we place x squared and y squared. We need to notice on which axis are the foci and the vertices located. And they're both on the y-axis. So that tells us that if this were graphed, it would look something like this. The two curves would cross only the y-axis. So y squared needs to be the first variable followed by x squared. So that is my answer for number 23. All right, just wanted you to have another look at this standard normal curve. So, and the percentages within the intervals. So let's see, what do we have? The runners' ages are normally distributed with a mean of 72. So let's just build to the right and to the left from 72 using standard deviation of 10. So that would be 82, 92, 102. And then going to the left, 62, 52, and 42. All right, I'm not going to draw the whole curve, but maybe I'll just do a little this. Okay, so within the intervals, within one standard deviation of the mean, remember this represents 34% and another 34%, total of 68%. Going out to two standard deviations, we pick up another 13.5% on either side. And then that final, the third standard deviation, gets us our other total of 5%, but it's 2.5% on either side. All right, so if you add all those percents up, you should have 100%. Okay, so let's see what we got here. We want to know how many. So don't forget, some of you on the last test, you just gave me percentages, but we're looking for find the number of runners. And we had 400 total runners participating. How many are between 72 and 82? And so between 72 and 82, that would be 34% of the runners. So 400 times 34% should be 136. And that is correct. Okay, what about runners that are less than 72? Well, now we're talking about 50% of the runners, because from 72 to the left, that would involve all three of these percentages added together, which should be 50%. So obviously 400 times 50% is 200. So that's my answer for number 25. And then what about between the ages of 62 and 92? So let me erase this. So we're talking about now from this range, from this data point over here, and if we add these percentages up, 34% plus 34% is 68%, plus another 13.5, that's 81.5% of the runners are between these ages. So we need to do some multiplication. So 400 times 0.815 gives us 326 runners. Should have said runners at the end of each one of these, I guess, but to put a little context into it. But that's those are your answers for 24 through 26. We just have one more. This little right triangle trig problem that we had much like on your last test. So let's just go ahead and draw the triangle. I think that helps. D is the right angle. So I'm just going to call this E and this F. And what else are we told? We're told that F is 47 degrees. And side D, which would be the hypotenuse, is 44. So we got to find side F, side E. Remember, those are small letters, and then angle E. Okay. Well, let's just work on. I guess we could go ahead and get angle E first. That's pretty easy. We're just going to do 180 degrees, starting with, because that's the sum of all three angles, minus 90, minus 47, and that ends up being 43 degrees. Okay, so how are we going to find these other sides? Well, we've got some choices. I could go with either one of these angles. It really doesn't matter. But what if we looked out from angle E and we did the sine ratio, which is opposite over hypotenuse, since I know what the hypotenuse is. So to find this side E, I'm going to use the sine function. Sine 43 is equal to the opposite side, which I'm calling E, over the hypotenuse. Let's put a little colon there. Here's how we're going to find side E. Okay? Hopefully you understand why we're using sine, opposite over hypotenuse, and we actually show opposite over hypotenuse on the right side of the equation. So to find E, we basically just have to multiply by 44 on both sides. So do in your calculator 44 sine 43, and that's going to give us side E. Let's see what we get. 44 sine 43, and that comes out to be 30.000. We're rounding to the nearest tenth, so we're just going to say that E is approximately 30. And that makes it pretty easy to find F, because now we can use the Pythagorean theorem, which says the hypotenuse squared is equal to one of the legs squared plus the other leg, in this case F squared. All right, so in your calculator, let's do 44 squared minus 30 squared. That equals F squared. 44 squared minus 30 squared. And that's F squared, so to find F, we need to take the square root of that number. So let's see what that is. We do the square root of that number. We get 32.186, but since we're rounding to the nearest tenth, we're going to say 32.2. Okay, so let me just circle our final answers here. We got F is 32.2. We came up with E as approximately 30, and hopefully you see how we got that. Hopefully you can follow the progression of how to get E and F, and then angle E was probably pretty simple, just subtracting from 180. Okay, well that concludes this review sheet. I hope you will take advantage of this video and then go back and do your own practicing, whatever problems you feel like you're the weakest on. And please let me know if there's anything I can do to help.